Hey everybody, I think this week I'm going to try to get both your videos out to you today, so that way you can just get everything done if you choose to. So the first video is going to be on certain special angles, so they're called corner angles. So we're going to do some sines of trig values and reference angles. They're all related. They all deal with this thing called a unit circle. So if you were to ever look something up when it comes to trig and trig values, usually you see this thing called a unit circle, because like radians, remember we talked about radians and everything was over r, which was a radius, and measure over the arc length and stuff like that. So everything's based on this circle, and the unit circle has a radius radius is equal to 1. So what that means is every single point here is only 1 away from the center. So this point here would be 1, 0. This point up here would be 0, 1. We would have negative 1, 0, and 0, negative 1. So those are the points. All right. But remember, I don't know if it was last week or the week before, I talked about the angles. If we're on the x-axis here, that's 0 degrees. If we're up here, this is 90 degrees. This is 180 degrees. This is 270 degrees. And 360 is the same thing as 0. Now you could do is exactly the same thing, but in radians. Do the radians in green. So 0 radian. This is pi over 2. That's pi. 3 pi over 2, and 360 is 2 pi. So again, the blues right here is my degrees. The green is my radians. I'm just going to scoot mine over so I have a little bit more room to write some stuff for you. But yeah, the unit circle is kind of useful. There's more we could add to it. I usually don't teach it that way. Some teachers do, where they have all these points and they just they make it look like a bike wheel almost, with all the spokes. We don't need to do it that way because I like to teach it a little bit easier. I don't know, I find it easier. So the corner angles. These are the corner angles. And if you kind of look at it, think about it, you have all these corners of this. I guess it's really not a corner of a circle because that really doesn't exist, but the corner of each quadrant. So based on the quadrants, the sine of an angle is the y value. It's really technically y over r. But if it's the unit circle, everything's 1, so we don't have to worry about that. The cosine is the x value, and the tangent is y over x. Okay. Now, again, here since r is 1, we don't necessarily need to worry about that. But I just want to show you how you would use those to evaluate some things, okay? So let's say we have the sine of 90 degrees. So what I'm going to do is, well, I know the sine's the y value. So I'm going to go to 90 degrees, which is on my unit circle, right here. And then I'm going to look at the y value of that point, and it's 1. So the sine of 90 is 1. Let's do the cosine of 0 degrees. The cosine of 0, well, the cosine is the x value. So go to 0 degrees, right there, find the x value, it's 1. Let's do the sine of 180. So sine of 180 degrees. Well, again, go to 180, sine is the y value. We look at the y value, it's 0. Let's do the sine of 270 degrees. So the sine of 270, go to 270 degrees. Sine's the y value, -1. Now, let's try something like the tangent. Let's do the tangent of 90. And tangent, again, y over x. So you have a restriction there when it's y over x, because x can be 0. And in this case, it is. It's 1 over 0. So that is undefined. That's an okay answer to get when it comes to trigonometry. However, the cotangent of 90, the cotangent, you would flip the tangent. So really this is 0 over 1, so it's 0. Okay, because remember, cotangent is the reciprocal of tangent. So you flip the fraction. We could do a boatload of these if we really wanted to. But as long as you're cool with the reciprocals and stuff, let's do another reciprocal one. Let's do like the secant of 90. Alright, so secant's the reciprocal of... So yeah, these are all individual problems here. Secant is the reciprocal of cosine. So this is really r over x. In this case, it's going to be 1 over whatever my x value is, because the unit circle always has a radius of 1. But my x value at 90 is 0, so that means the secant of 90 is undefined. I don't know what other ones to do that would be tricky. I don't know. Cotangent? Another cotangent. Let's do cotangent of 270. Okay, cotangent 270 is, well, there it is. If the tangent's y over x, this is really x over y. So I'm going to have 0 over -1, or just 0. These three things right there, ooh, didn't really circle those nicely, or box them in. Those things in this circle are gold when it comes to evaluating things, okay? If you can, and oh god, the amount of times you would use this in calc isn't even funny. Only because you're going to be expected to know these values. All right. Cool. Let's talk about the signs of trig values. So the signs. Again, we're going to go back to that graph with the unit circle. I'm not necessarily going to draw the circle though. We're just doing x and y axis, okay? In the first quadrant, okay, quadrant 1 is up here, quadrant 2, quadrant 3, quadrant 4. You have the sine, you have the cosine, and the tangent. Each quadrant, these things exist, but the signs, like not like the sin sign, but the positive negative sign switches. Okay, so in the first quadrant, all of them are positive. In the second quadrant, sine's positive, but cosine and tangent are negative, right? And if you think about why, well, remember, cosine and tangent both had x values in them, and we're in the negative part of the x coordinate. So now here, sine is going to be negative, cosine is going to be negative, but tangent is positive. And again, that's because tangent involves y and x. But if they're both negative y and negative x, it becomes positive. And then in this last one, sine's negative, cosine's positive, tangent's negative. I don't know if you've ever heard there's not really an acronym. I don't know what they really call them, like, but it's I know there's a name for them, but where you learn things by creating a phrase. But we usually say all students take calculus. And that means in the first quadrant, they're all positive. In the second quadrant, just sine. In the third, just tangent. And the fourth, just cosine. So all students, or all seniors, whatever you want to say, all students take courses, all students take calculus, something like that. All students, I don't know what other ones we could create. I don't know, but that's cool. Those are your these right here. Another thing that if we were in school, I would expect you to kind of memorize. You are going to again need to know that for calculus. Kind of a big deal. So what we did in the last video, second video from last week, is we evaluated all trig functions based on a triangle, and you did a lot of Pythagorean theorem and stuff like that, where I had to give you the value of the trig function. So we're going to do a few of those, and then we're going to jump into reference angles, but only because we did them on the last video. I do want to briefly review them. So it is going to be dealing with these because we're going to draw a triangle, and it's going to be based on the what quadrant we're in here. All right, so let's say the cosine of the angle is equal to -12 over 13. All right. Now you can't just be given that, because cosine's negative in two quadrants. It's negative in the second quadrant and the third quadrant. So I don't know where I would end up drawing this triangle if I was to draw it somehow here. So I have to give you more information, right? I could say cosine of the angle is -12 over 13, and I could also say the tangent greater than 0. Tangent being greater than 0, what that means is tangent's positive. So therefore, that means I am in the third quadrant because of that, this second condition. So I know I'm in the third quadrant. I can draw my triangle. Now, if we remember correctly, cosine is x over r. So that means this is -12, and my radius, or my hypotenuse, is 13. The angle is always at the origin. Angle's always at the origin. Angle's always at the origin. Yeah, 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 yeah. All right. So now we do a Pythagorean theorem, but if you know this is a special right triangle, this is a 5, 12, 13. All right. But if you don't know that, a squared. Ooh, dear, that's a horrible squared. What the? A squared plus 12 squared, because it's going to get squared either way, equals 13 squared. 13 squared. What the heck is going on? Alright, so a squared plus 144 equals 169. Subtract it. Shazam, a squared is 25, so a equals 5. Okay, so this is 5. However, it's not just 5. It's negative, because again, you can look at, you're going down. We're in the third quadrant, right? Y is negative. So now we can evaluate all 6 trig functions. We got sine, cosine, tangent, and we're going to do secant. Oh, cosecant first. And cotangent. Alright, so sine. Opposite over hypotenuse. -5 over 13. Cosine was given to us. -12 over 13. Tangent. Opposite over adjacent. 5 over 12, because it's really negative 5 over negative 12, but the negatives cancel out. Then the reciprocals, we just flip them. Negative 13 over 5, negative 13 over 12, 12 over 5. Done. Now, do you need to draw this on the origin? You don't. Other teachers, and actually that's the way I used to teach it, I would just draw the triangle, everything positive, and then I would use the signs based on the quadrants we're in. Because based on the quadrant we're in, only cotangent and tangent would be positive, so I had to make sure everything else had a negative sign. That's another way to do it. Maybe we'll do the next one like that, so you guys can kind of see a different way of doing it. So, example again. Let's do the sign of the Pokeball is negative 2 over 5. That's right, Kyle. I said Pokeball, like Pokemon. So tangent is less than 0. Sine is negative, tangent's less than 0. That means tangent's negative as well. Sine and tangent, both negative. That's in the fourth quadrant. Okay. So I'm just going to jot that down to the side. But what I would do now is I would make my triangle. I'm not doing this on the circle. I'm doing it the other way because I wanted to show you two ways of doing it. Sine is opposite over hypotenuse. Hypotenuse is always positive. You can't have a negative hypotenuse. So we're going to have negative 2 over 5. I'm going to find that missing side. So negative 2 squared plus b squared, 5 squared. So we get 4 plus b squared equals 25. Ooh, not squared anymore. B squared equals 21. So that missing side is root 21. Let's move my work out of the way a little bit. So this is square root 21. So now I'm going to do them all. Cosecant, secant, cotangent. Alright, I know I'm in the fourth quadrant, so only cosine and secant are positive, so I'm just going to already put my negative signs in for everything else, because I wouldn't have to worry about this negative 2. Okay, sine, opposite over hypotenuse, so 2 over 5. It was also given to us. It's negative. Cosecant, flip it. Secant, not secant, sorry, cosine first. Adjacent over hypotenuse. Root 21 over 5. Secant, 5 over root 21. Don't worry about rationalizing the denominator. You can if you want. You don't need to do it. Tangent, opposite over adjacent. 2 over root 21. Cotangent, just flip it. Root 21 over 2. That's it. Sometimes you'll be given tricky ones. All right. And I don't know. I like to give them to you only because technically they should be no-brainer type questions, but a lot of people fall for the traps on them. All right. So let's say I'm going to tell you the tangent is undefined. Okay. Tangent is undefined at 2 spots. All right. So I also have to give you the other condition. Oh, look at me throwing radians in there right now. Oh, yeah. So between 0 and pi. So what that means is I'm up here. This is 0, pi over 2, pi. Okay. So I'm up there. But if you're undefined, what does that mean? Well, that means you're dividing by 0. So it's really 1 over 0. So there's no way for you to make a triangle based on that. So really what you need to now know is those corner angles that we first talked about in the video. and figure out where is the value y over x 1 over 0. Well, if I go 0, 1, right, 0, so this is the point 0, 1, that's at 90 degrees. Oh snap. So I know my angle is 90 degrees, or pi over 2, whatever you want to write. That's going to give me every piece of information I need now. Because the sine is the y value, 1. The cosine is the x value, 0. Tangent was given to me. Cosecant, you flip that, it's still 1. The secant, flip 0, now you get an undefined answer. And cotangent, flip undefined, and you get 0. Hey. Alright, so that is kind of taken in the triangles, corner angles, everything we've kind of done into one big thing. Alright, so we'll kind of move on from that, because I don't want to hammer that too much, because we did do that on last week's video as well. Let's talk about reference angles. All right, a reference angle, all reference angles are between 0 and 90 degrees. All of them, all of them, all of them, all of them, all of them. And that is because a reference angle is really the shortest, well, yeah, let's say that, the shortest, in quotes, because I don't know if that's really the way we should word it, shortest way to get to the x-axis. All right. So, what the heck does that mean? Well, let's say we have the angle. Oh, that's a highlighter. 211. Now, remember when we sketched angles, we started on the x-axis. We would go around and do stuff. Well, 211 is somewhere here. Like this would be like 211. I'm just guessing. But I want to know the shortest distance, or the shortest way to get to the x-axis. Well, the shortest way to get at the x-axis is right there. So what I need to do is to really subtract all this garbage, and I'm given my reference angle. So if I subtract that garbage, which happens to be 180, so if my angle is 211 degrees, my reference angle is really 211 minus 180, which is 31. Now, is there a way to simplify all of this? Of course there is. Okay. Anything in the first quadrant, your reference angle is your angle. All right, so I don't even know how to word it. But I'll kind of give you the general thing here. Oh no. Well, that works. So these are the angles. So no reference needed. All right. But to do it here, what you're going to do is you're going to take your 180 minus your angle, and that equals your reference angle. That's only in quadrant 2. In quadrant 3, you do your angle minus 180. Then, if you're in the last quadrant, in quadrant 4, you do 360 minus your angle. So the first thing you would have to do is determine which quadrant we're in. And if you're greater than 360, you got to subtract a 360 from it until you're between 0 and 360. So for this to work, you really have to be between 0 and 360 degrees for this little chart that I'm doing here. I'm using my hands, like you guys can see my hands. It's really weird. I gotta take a drink of water to stay hydrated. All right. Yeah, because this right here, again, it's key, because let's say you have an angle that's greater than 360. Let's just do one for poops and giggles, because we can't swear. I think I'm going to have a hard time with that once we get back to work, because not working, I've realized that I swear a lot. And now my kid's learning to talk a lot more, and I really have to watch my mouth. 470 degrees. So that is my given. So right, so that would make my pokeball, right? My angle is 470 degrees. However, 470 degrees is greater than 360. Like, there's 360 right there, right? But then I got to keep going. So 360 plus 90, right? 360 plus 90 is, what is that, 450? So I still need to keep going. So somewhere around here would be my angle, right? So let's say that's my angle. That's great. But I don't know really what I want to look at is this thing. So that way I can just do that 180 minus it. Okay, so what I'm going to do, since I've looped around, is I'm going to subtract 360. By subtracting 360, we're going to make a life a lot easier. So we get 0, 1, 1. So we get 110 degrees. That is not a reference angle. That's what we call coterminal angle, because it does have that same line here, right? But now I can use 110 and use my cheat thing I got up here. So 180 minus 110 is my reference angle. So my reference angle, 70 degrees. Make sure you're between 0 and 360. You'll be set. This can also go for if you have a negative number. Right? Let's say I have a negative 268 degrees. Why that? Because it's the one I wrote on my paper, because I wanted to do a negative one. No significance, just some random number that I jotted down. Negative 268. So, well, this is negative 180, and that's negative 270 here. So I'm really close to it. So again, I'm in my second quadrant. So now if I want to know my reference angle, well, I gotta first get this has to be between 0 and 360, and it's not. So what I do is I find a coterminal angle by adding 360. So negative 268 plus 360, get 92 degrees. Okay, there it is. So that means this guy is 92 degrees. So my reference angle is 180, because I'm in the second quadrant, minus my angle between 0 and 360, so 92. And I get 88 degrees. Now, what happens if I give it to you in radians? Dun, dun, dun. I heard everybody sigh at once. Like, I'm picturing myself in my classroom right now, and everybody just went, ugh. You know, and then I look at you and I go, it do be like that sometimes, or it be like that. I don't even remember the saying anymore. I guess I've been out for too long. But let's say we have 11 pi over 6. Ah, crap, 11 pi over 6. Whose idea was this? So let's first convert it. 11 pi over 6 is, remember, to convert radians to degrees, you multiply by 180, divide by pi. So that goes away. I think this becomes 30. So 11 times 30, or 330 degrees. Okay. Now we can deal with this. 330 degrees, fourth quadrant, right? So that means I have to do my reference angle is 360 minus my angle, which is 330. So my reference angle is 30 degrees. 30 degrees. Right? I think I'm coming up to the half-hour mark. Yeah, I am. So I think we're going to call it quits. All right. So this is going to basically be what your homework is on. A lot of reference angle stuff. Yes, you are going to have to convert between radians and degrees. Using the signs, SOHCAHTOA. All seniors take classes. All seniors take calculus. All students taste cheese. I don't know, but a lot of times, yeah, we're gonna be using this a lot. So the next video, I think, what do we have? Oh, we're just gonna be doing more with reference angles. Yeah, here it is. This would be your last lesson of the test. We would have a test after the next lesson. So you're going to be using reference angles with no calculator type of stuff to basically find all 6 trig functions and such. We're going to use special triangles, 30, 60, 90, 45, 45, 90s, finding missing angles, finding the angles, given the sides. We're going to be kind of busy in the next video. So we'll talk to you guys later. We'll see you in the next video.